Hello friends, welcome to my YouTube channel Computer Science Classes by Nikhil Srivastava. And in this video we will study about what are indexes. So indexes, if you read this PowerPoint presentation, then indexes are used by queries to find data from tables quickly. So and then if you read the second line, then it states that if there are no index to help the query, then query engine performs the entire table scan. Let us try to understand this with our table. So this is my table, and suppose I say again, I will write this is my employees table. Okay, so here I've got my employees table, and now I want to issue one query. I want to find the name of all employees whose salary is, say, suppose 50,000. Then what will I say? I will say select ename from employees where salary equal to what? It is equal to 50,000. So you have found one employee, that is Sonali. So how is this query executing? How is this query executing? This query is executing in a very simple way. What is this way? I will just explain. I'll just explain it to you. For example, what is happening? I'll just take the pen tool, and it is because it is a select statement, so it is going to every row, and it is testing if the salary is equal to 50,000. No, it is not equal to 50,000. Then again it is going to the next row, then in this row, so it is going to each and every row and then finding whether the salary is equal to 50,000. So for example, in the case of Sonali, it is finding that salary is 50,000, but it has to scan the whole table. It has to scan the whole table. This whole table it has to scan. Every row it has to scan to find for which employee the salary is, say for example 50,000. It has to scan the whole table. So this is the what is happening right now. But so you can test this also out. For example, I just say that this is my I'll just come over here, and what I will write, I will say, suppose explain this query. So explain is it is it tells you about the performance related configurations with the query. For example, if you just see over here, for example, if you observe that here the number of rows which have been scanned are equal to 10. So in effectively, for finding the salary of for finding the name of all employees whose salary is equal to 50,000, a whole table scan was done. Okay, a whole table scan was done. So this is not a very efficient approach. So for example, I say that I'll just take a paint, and for example, I say that you have a table, and inside the table you have, say, suppose 50,000 rows. Okay, how many rows? 50,000 rows. It's a big number. And then you have to so these are the number of rows. Okay, so these are the number of rows in a table, and then you have to search for a value, say suppose 3,500. Okay, you have to search this value. So it is almost like performing a linear scan of all these 50,000 values. So you will have to make 50,000 comparisons. You will have to make 50,000 comparisons. So this is not very advisable. So for solving this we use the concept of indexes. So here you can also see that for finding a name of the only one employee was returned, but for just finding the name of that employee, that was Sonali, I was searching how many rows? I had to search 10 rows. Okay, and if the table is very big, suppose it is contain 1 lakh rows, then you'll have to search how many rows? You'll have to perform a linear search of 1 lakh rows, and this is what is exactly stated over here. If you just if there are no indexes, the second line, if you see, if there are no indexes to help the query, then query engine performs the entire table scan. So so many times it happens that in your where clause, for example, I have written this in where salary is equal to 50,000. So many times you have to perform some scanning on the table based upon some where clause. So in where clause you are using some columns. For example, I can say where suppose gender is equal to male, gender equal to what? Gender is equal to male. So again, it is scanning 10 rows for it. So you are performing searching based upon the condition that you have given in your where clause. So many times it happens that in some organization, for example, frequent searches have to be performed against some columns. For example, here in the employees table, there may be very frequent searches against the salary column. So in that cases, it is advisable that I create an index on this column. Which column? The salary column. I create an index on this column. So what does this exactly means, to have an index on a table? We will try to understand this. So I'll just again I'll again select the table, select start from the employees table. This is my employees table, and I'm just now to create some space. I'll move it up, and now I'll take the pen tool and try to I'll try to explain it to you in what way an index can actually help. So okay, so what an index is gonna do is that index is going to if you create an index, for example, on salary, you create an index on this table on salary. Okay, so what it is going to do, it is going to sort the salary. Okay, it is going to sort the salary. So suppose I say I'll just escape it, and I say select a salary from employees and order by salary. If I say something like this, this is the sorted order of salary. This is the sorted order. This I've got the sorted order of salary. Now again, let me explain it by using a pen tool. If you go over here, okay, so what if I create an index on which column? Suppose I create an index on the I think I need to change the color. If you create an index on, say, suppose the salary column, okay, which column? The salary column. So what it is going to do, see, this table is saved over here. Table is it is stored over here, but what it is going to do, it is going to allocate some different memory. Okay, it is allocating some different memory for the index, and it is going to store the your which values, your salary values in sorted fashion. Okay, so first it is going to store what? It is going to store sorry, and just first it is going to store 50,000, then it is going to store 30,000, and then it is going to store 34,000, and similarly all the values in sorted order. So I've got this sorted order. So somewhere in the memory a space for index creation will be created, and all the salaries will be listed in which order? In the in sorted order. In MySQL, this the order of sorting is by default ascending order. So it is it will arrange them in ascending order. So this is 60,000, suppose 67,000, and and so on. For example, 70,000 and 80,000 and suppose 1,20,000. So okay, I think so. Again, what it has done, it has, so in a separate this is space, I'll say it, suppose this is the space for index. Okay, an index on which column? On the salary column. So it has stored all the salaries in which order? In the ascending order. And now it is going to do something like this. For example, this, so it it may or may not happen exactly like this, but I just want you to give an idea. The idea is the idea of a textbook. Suppose if you study from some textbook, then a textbook always has an index. Okay, so how how you work with index? You suppose you have to go to certain lesson, then you find at which index position at which page number this this lesson is at, and then you move on to that. You don't have to search the whole book for finding that lesson. You use the index that is given in the book. So this is it is almost analogous to this. For example, this these rows have certain address. Suppose the address of this row is, say, suppose I'll write the address is suppose X. Sorry. Alright. The address is, say, suppose X1. The address of this row is, say, suppose X2, and suppose I'll write it over here. Okay, the address is, suppose first row is x1, the second row is x2. You know, every row will have specific addresses. Suppose the fourth row address is x4. Then what it is going to do, you know, it is going to associate these sorted salary values with the address of the actual rows. For example, you know, for sorry, I made a mistake. You know, for example, this, you know, which employee has a salary of suppose 15,000. This Rashmita has a salary, Rashmita has salary of 15,000, and suppose it is associated with address x, suppose x15. Okay, it is associated with address x15. So with 15,000 it will associate which value? It will associate x15. Now the second, you know, the second lowest salary is what? 30,000. Suppose the address with this row is x27. Okay, so what it is going to do with 30,000, it is going to associate the address value x27. Now what is the, again, you know, it is 34,000. So 34,000 is this row. Suppose this row, the, you know, the 30, you know, this row, Wasim row, it is at address, say suppose suppose x59. Then against, you know, 34,000, it is going to it is going to save also what? X59. Okay, so it is going to store the salary values in ascending order, plus, you know, the address of the specific rows in which, you know, these salaries are found. For example, 50,000. So 50,000 is, you know, suppose 50,000 it is over here, and it is found at address x68. Then it will, you know, for against 50,000 it will save the address x68. Okay, it is going to store all the values like this. Now, you know, for example, I want to search for some salary. Suppose I want to search for 40,000, you know, then what it will do, it, suppose now if you want to search for the employee whose salary is 40,000, so it will not go to this table. It will not scan the whole table. You know, previously what I was doing, I was searching for the employee whose salary is 50,000, and, you know, for that the whole table scan was done. But here it is, what it is going to do, since these values are already sorted, it is going to, it will go to which position? It will go to the position, you know, where the salary is what? Where the salary is 40,000, and, you know, it will fetch the address that is, you know, associated with the row of, you know, the row that has the salary 40,000, and, you know, it will directly fetch the values from this row, you know. Alright, you are getting it. For example, you know, I say that I want the name of the employee whose salary is 50,000. Then, you know, it will not have to, you know, search all these values, because all these values are already sorted. It will go to this value that is 50,000, and, you know, it will take out the address that is associated with the row that has 50,000. For example, you know, 50,000, this was associated with, you know, the row of Sonali. So this row has, suppose, the address what? It has the address x68. This row has the address x68, and then it will fetch the name from this row. That is what? That is Sonali. So in this way, you know, these indexes are working, and, you know, a separate space for index is allocated. Okay, the table, you know, the table is allocated over here. This is the space for allocation for the table, and this is space for what? This is space for allocation of the index. All right, so remember this. These are, you know, these are a special kind of indexes. We will study in the next video that these are secondary index. For secondary index, you know, always a separate storage space is allocated. So this, you know, in which, you know, the index values, you know, the column on which you create an index, all these values plus the addresses of the corresponding rows is saved, and then, you know, you can perform fast lookup through those, you know, through these sorted values. For example, in this, you know, salary, I can perform, because these values are sorted, I can perform very fast lookup in the table through this index. Okay, so I will, you know, I will try to I will show you also practically. So before showing, let us see this. You know, if you have to create an index, then what command you use? You use this command, create index, the name of the index and the table name. Okay, and then, you know, the column name you have to specify on which you are creating index. For example, if I go to my database and this is my employees table, I want to create an index. So what will I say? I will say create index. Suppose the name of index is index2, index2. And then, you know, on the table name, on which table, the name of the table is employees, and which column of the table? The salary column. suppose now I have created the index on the salary column of the employees table. Now what you do? Now you do something like this. Select star. I think I just know. I'll go a little slowly. I will first of all drop this index. How do you drop the index? Drop index name on table name. So what if I need to drop this index, then what will I say? Drop index what? Index 2 on which table? On the employees table. I'll first of all drop this index. Let us write this query. Select ename from employees where salary equal to 50,000. Okay, so you are getting Sonali because Sonali's salary is 50,000. And now if you do one thing, you do explain of this query. You do explain. Okay, so this I have already taught you. So if you just observe how many rows can have been made, 10 rows can have been made. But now I do something different. I create an index on the salary column. So how will I create an index? I will create an index like this. I have created an index, and now if I say what? I say select star from select ename from employees. I think okay, select ename from employees where salary equal to 50,000. Then also, in both these cases you are getting the same result. Then what is the advantage of indexes? If you just try to now explain this query, what is the performance issue related with this query. So if I do explain of this query, now you see how many rows can have been made. Only one row has been made. Why? Because you have created an index on which column? You have created an index on the salary column. And now because you have created an index on the salary column, it is not being, the whole table scan is not being done. It is going to the place where index are allocated, and from that index it is performing a very fast lookup on your table. So you can just imagine this table is only, it is containing 10 or 11 records. If the table has so many records, for example 1 lakh records, there are many tables like that. So an index can perform very fast lookup. So your query can become very fast and very optimized. Okay. So this much is clear. Now again, if you do something like this, I say suppose I say on commission, where commission is equal to 50,000. See, again, since you have not created an index on which column, you have not created an index on commission column. That is why when you are explaining this query, you are then again in this case also you are performing what? The whole table scan you are performing. But I can do something like this also. I can create an index on which column? I can create an index on the commission column also. How can I create an index? I will say create what? Index. I will say index. Suppose the name of the index is index 3 on which table? On the employees table. And which column on the employees table? Suppose the commission column. And I have created the index on which column? On the commission column also. So now again if I go and perform this, then again the rows have been previously when I was performing the query, it was performing a scan for 10 rows. Now it has just performed a scan of how many rows? Of only 1 row. So this is the advantages of using indexes. Okay, so if you want to very frequently perform some search operations on some columns in the where clause, you generally you create an index on those columns. Okay, so this much is clear. So now I will introduce you to something different, and that is the metadata information related with the views. So how can you find the metadata related information? There is one view and that is information underscore schema dot db underscore sys dot tables. Okay, if you describe it, then you are getting these columns. Suppose I want the table ID from the table name. So what query will I issue? I will say something like this. What will I say? Select table underscore ID from tables where name is equal to what? Name is equal to publishers, the name of the database is publisher. So I'll first put the name of the database, and then what is the name of the table. So this is my employees table, so this is the metadata view for, I'm sorry, there is some problem with this. Okay, select table ID. Okay, I have not put the from over here. I'll just put it from. Yeah, so you have got the table ID of the employees table to be what? You have got it to be 1446. Okay, so now what is gonna happen? So this is what kind of view it is. It is information schema InnoDB sys table. So it is fetching the metadata information of the tables. Now I want the metadata information of the indexes. So what will I do? I will do something like this. I will not say table, I will say indexes. So you are getting this. See, I have fetched the the table ID of the employees table, that is to be 1446, and now I will fetch the see here my database is what I know. On a side note, just on a side note, what is the name of my database? It is publisher. So that is why I've used the name of the database followed by the name of the table. I found the ID of the table. Now I write something like this. What do I write? I write something like this. Select star from information and and I say indexes, where what? Guess what? Table underscore ID. Table underscore ID is equal to what? It is equal to what was the ID of the table? It was 1446. 1446. Okay, let us go. So you can see that there are two indexes. What was the name of the first index? It was index 2, and the second index, what? It was index 3. See, here I created these two indexes on the employees table. So you are getting the metadata information. One was index 3 and other was okay, index 2. So I have created these indexes, and you are getting the metadata information related to these views. Okay, and forget about this. This is the clustered index of it is created on the primary key of the table. So we will discuss this in our next video, but for now you can just remember this one thing, that that for these secondary indexes. So the kind of indexes that we have studied till now, these are all secondary indexes. And what is the identification for secondary indexes? Secondary indexes are allocated differently. There is an allocation for the table, and there secondary index had their different allocation. That's what we saw previously when we created an index on the salary column. So I think I'm just done with this. So yeah, I'll just take one more example. I'll create one table. I'll create the table, say suppose test 5, and in this column I will add suppose serial number, that is of type int, and then I say I'll insert some random values in this table. Insert into what is the name of the table? Test 5, and value. Suppose first value is 10. I'll randomly insert some values. Suppose the next value, say suppose 1, suppose 13. Okay, all right. Then I say the value 5. Then I insert the value 1, and then I insert the value, say suppose 11, and then I am inserting 9. One more to go. I suppose insert 4. Okay. So if I say select star from test 5, you are getting this these values. You are getting these values. Now, what I am going to do is that I am going to create. Suppose I say select serial number from test 5. Okay, select serial number from test 5. Okay. So you are getting these, and in which these rows have been stored in generally you can just see that they are stored in the order of their insertion. But now let me create an index on the serial number column. How do I create an index? I will use a create index. Create index. Suppose the name of index. I'll just give some proper name to this index. So what is the name of the table? Test 5 underscore suppose serial number underscore index. It's a proper name. Okay. So test 5 on serial number column we have created an index. Create index name on which table? Test 5, and which column on the test 5 table? The serial number column, and I have created an index. Now what will I do? Now if you say select a serial number from which table, from test file table, what you are getting? You are getting sorted record. Okay, so I think it must be clear, because you know what it is happening, what is exactly happening over here. See, you have created an index on which column? You have created an index on the serial number column. So you know it has stored serial number in in sorted ways, 1, 4, 5 and 8 and 10, and what we just saw previously. For example, the address of this row is it is x55. Then against this 11 value, it is storing which address? It is storing this address x55. So these allocations, these are dependent on the database server. So it is just to give you an idea. There may be some different kind of allocations. I read it somewhere, these addresses are not stored. Sometimes the primary key values are stored. So there may be different kind of allocation, but you just get an idea that it is searching. It is almost like a textbook searching some content in a textbook through the index. Okay, through the index of the textbook. It is almost like that. So you have created an index, and now you can do something like this also. First of all, let us find the the ID that is associated with this table. So what is the name of the table? The name of the table is test5. So what is the ID that is associated with this table? The table ID is 1576. For test5, the table ID is 1576. And now I can write something like this. What can I write? I can say, suppose select star from information schema indexes, where it is equal to what? 1576, and you will get what? There is one general clustered index, we will discuss it later. It is just the index that that is it is a kind of clustered index. We will see in the next video, but it is just storing, it is storing the data of the table in the order in which it was inserted, and we will deal it with in the next video. But here you can see we have created one index, test5 serial number index, and it is what kind of index? It is a secondary index. Always remember, the type 0 specifies a secondary index. Okay, so here we are using a secondary index. Okay, and if you write something like this, explain select serial number from test5 where serial number equal to 5. If you write like this, serial number equal to, you are going to what? How many rows will be searched for, scanned? Only one row will be scanned. Okay, so thank you so much for watching my videos. Please do keep on watching, liking, subscribing all my videos, and do give some comments on how I can improve my the quality of teaching and the quality of training. If there are some flaws with my style or my content, please do tell me about it. I'll be very thankful to you. Okay, thank you so much.